I've already talked a little bit about proportions, and now I'm going to talk about how we can estimate what a population proportion is using a sample proportion. Let's say we want to know what percentage of people in the population are left-handed. It would be impossible for us to measure every single person in the world, so what we can do is take a sample of, say, 500 people and create a sample proportion. So let's say that in our sample, 75 of those 500 people are left-handed. So we can use that to calculate the sample proportion, which is this. P hat, P with the little triangle over it, is the sample proportion. And we find that by taking x divided by n. X in this case is the 75 people we found, and n is the size of our sample, which is 500. So when I divide 75 by 500, I find a sample proportion of 0.15. What that's basically saying is that we expect 15% of the population to be left-handed. Now we can also find out how the sample proportion is distributed. So for example, we can find out the distribution of the sample proportion if the sample size is less than 5% of the total population size. Also, we can know if the distribution of the sample proportion is approximately normal based on this equation, which is just np times 1 minus p. If that is greater than 10, that means our distribution is approximately normal. And we can also calculate the standard deviation of a sampling distribution using the equation below. So let me give you an example of how to do all of this and what that means. So first of all, in our sample of 500 individuals, 75 are left-handed. How can we describe the distribution of the sample proportion? So first of all, we have to meet those criteria I talked about. Is the sample size less than 5% of the total population size? In this case, it definitely is. 500 is definitely less than 5% of the world's entire population of billions of people. So we can do this. And now, is the distribution approximately normal? Well, if I plug the numbers into that equation that we found before, where n is 500 and p is 0.15, we find out that 63.75 is greater than 10. This means that our distribution is approximately normal. I don't want to get into entirely what this equation means because it's a little bit beyond the scope of what I'm talking about right now, but just know that this means our distribution is approximately normal. And now I'm going to use this equation to calculate the standard deviation, again where n is 500 and p is 0.15. And if I plug things into that equation, we find a standard deviation of 0.016. So the mean, in this case, is 0.15, and the standard deviation is 0.016. So if we take these two values, I could actually construct a distribution. We know this data to be normally distributed, or we're assuming that it is at least. So we can just plug it in like that with the mean of 0.15 and the standard deviation of 0.016. It would look something roughly like that. And that's how you can draw a distribution of a sample proportion. And that's it for sample proportions right now.